1.3.0 Rigging hardware. Rigging hardware is as crucial as the crane, the sling, or any specially designed lifting frame or hoisting device. If the hardware that connects the sling to either the load or the master link were to fail, the load would drop just as it would if the crane, hoist, or slings were to fail. So that's that old saying, chain's only as strong as its weakest link. 1.3.1 Shackles. A shackle is an item of rigging hardware used to attach an item to a load or to couple slings together. For example, a shackle can be used to couple the end of a wire rope to eye fittings or hooks. It consists of a U-shaped body and a removable pin. This is highlighted. It says shackles used for overhead lifting should be made from forged steel, not cast steel. Quenched and tempered steel is the preferred material because of its increased toughness, but at a minimum, shackles must be made of drop or hammer forged steel. All shackles must have a stamp that's clearly visible showing the manufacturer's trademark, the size of the shackle, determined by the diameter of the shackle's body, not the diameter of the pin, and the rated capacity of the shackle. Shackles are available in two basic classes identified by their shapes: anchor shackles and chain shackles. Both anchor and chain shackles have three basic types of pin design, each one unique as shown in figure 26. So here are shackles. This is a shackle. It has a pin. That pin screws in, and some of them have a cotter pin that keeps it from coming back out. Some of them have a hex nut, but also when you get that hex nut on, then you also put the cotter pin in and keeps that hex nut from being able to back off. Do not over tighten the shackle. You can damage the shackle and the pin can become damaged or stuck or cross-threaded. Wide body shackle. Here's a synthetic web sling shackle, and you can see how it's flat to accept that web slinging. When a screw pin shackle is used, it's important to tighten the pin the proper amount. The pin should be screwed in until it's fully engaged and the shoulder of the pin is in contact with the shackle body. If the pin is left loose, the shackle can stretch under the load. If the pin is over-tightened, the load stress from the sling can torque the pin even more. This can stretch and jam the pin's threads. So don't over-tighten it. And you always want to put the shackle on to where the load is hanging by the shackle, not by the pin. When any type of shackle is used in a rigging operation, it must be positioned so that the load is centered in the bow of the shackle and not on the shackle pin. If the shackle is uses a screw pin and the load is positioned on the pin, the shifting of the load could cause the pin to twist and unscrew. So this one's correct. They have the pin up here where it's not going to be moving, and then the load is attached to the bow of the shackle. Okay. Eyebolts, 1.3.2. An eyebolt is an item of rigging hardware with a threaded shank. The eyebolt's shank end is attached directly to the load, and the eyebolt's eye is then used to attach a sling to the load. So here's an unshouldered eyebolt. This is a shouldered eyebolt, and this is a swivel eyebolt. And it says swivel eyebolts are also called hoist rings. They're designed for angular pulls from 0 to 90 degrees from the horizontal plane of the load. In a few cases, eyebolts must be torqued to a specific value when they are installed for lifting purposes. 1.3.3 Lifting clamps. Lifting clamps are used to move loads such as steel plates, sheet piles, large pipe, or concrete panels without the use of slings. These rigging devices are designed to bite down on a load and use the jaw tension to secure the load. As you lift them, the jaw closes, so the more weight that they're lifting, the tighter they will clamp down on it. All lifting clamps must be made of forged steel. They must be stamped with their rated capacity. Some clamps, such as the one in figure 33, use the weight of the load to produce and sustain the clamping pressure. The grip tightens as the load increases. Others use an adjustable cam that is set and tightened to maintain a secure grip on the load. So here are different lifting clamps. Did you know shackles and pins? Pins should never be swapped in shackles. The thread forms of different brands of shackles and different brands of pins may not engage properly with one another. In addition, there's no easy way to tell how much reserve strength is left in a pin or a shackle. Further, the rated capacity of different shackles and pins may not be compatible. A shackle pin should be placed and secured into a single shackle between uses. And you can never replace that shackle, the pin. If you've lost the pin, you can't just use a nut and bolt to replace that pin. So here are some reasons why you reject the rejection criteria for lifting clamps: excessive rust or corrosion, if the lifting eye has been bent or changed shape, any of that cracks, abrasion, any deformation of other impact, damage to the shape that is detectable, excessive rust or corrosion, excessive wear of the teeth, heat damage, loose or damaged screw rivets, worn springs. 1.3.4 Rigging hooks. A rigging hook is an item of rigging hardware used to attach a sling to a load. There are many classes of rigging hooks used, but most rigging hooks fall into a few basic categories. Most rigging hooks have safety latches or gates to prevent slings or other connectors from accidentally coming out of the hook during use. Hooks that do not have safety latches are usually designed so that the latch can be added. So here's one with a safety latch. This one doesn't have a safety latch, but you could add one. Here's a grab hook. You see how narrow the opening is here? This is for chain links. The chain link will fit right down in this groove, and the other two are at 90 degrees to this one chain link, so it will not slide. Eye hooks are the most common type of end fitting hook. A rigging eye hook has a large eye that can accommodate large couplers. Reverse eye hooks position the point of the hook perpendicular to the eye. Sliding choker hooks are installed onto the sling when it's made. The hooks, which can be positioned anywhere along the sling body, are used to secure the sling eye in a choker hitch. This one's highlighted. It says grab hooks are used on steel chain slings. That was that one we're looking at. That's a grab hook. This is used on steel chains. These hooks fit securely in the chain link so that the choker hitches can be made and chains can be shortened. And then shortening clutches, a more efficient version of grab hook, provide a secure grab for the shortened sling leg with no reduction in the capacity of the chain because the clutch fully supports the link. And this is highlighted. It says, hooks used for rigging must be made of drop or hammer forged steel. Although most rigging hooks have safety latches or gates, some hooks used for special applications may not have them. So if a safety latch is installed in a rigging hook, the latch must be in good working condition. Damaged safety latches can be easily replaced. Any damage to a safety latch must be reported to an instructor or supervisor. And here are different rigging hook defects: wear or scraping, cracks, cuts or gouges, excessive rust, increased throat opening, if it's been twisted out of alignment, it's been elongated, or it has a broken or missing safety latch. 1.4.0 Hoists. A hoist is a device that uses pulleys or gears that provide mechanical advantage for lifting a load. I think that is a highlight. Allowing objects to be lifted that cannot be lifted manually. Some hoists are mounted on trolleys and use electricity or compressed air for power. In this section, a simple hoisting mechanism called a block and tackle and a more complex hoisting mechanism called a chain hoist are discussed. So here's your block and tackle, and basically they're doubling the weight that they can pull. they're only going to put 100 pounds of pressure on this tag line, and it's going to lift 200 pounds off the ground because they've doubled the pulling rope. You see how it goes down through this block and comes up to this tackle? There you go. Block and tackle is a simple rope and pulley system used for lifting loads. By using fixed pulleys and a wire rope attached to a load, a rigger can raise and lower the load by pulling the rope or by using a winch to lift the load. It says all chain hoists use gear systems to lift heavy loads. That's a highlight. The gearing is coupled to a sprocket that has a chain with a hook attached to it. The load is hooked onto the chain, and the gearing turns the sprocket, causing the chain to travel over the sprocket, move the load. So here's one they say is pneumatic. So it uses compressed air. This one's manual. You'll pull the pull chain, and that will lift the lifting chain. This one's electric. Be very careful. There's something called a come-along. It does not have a braking system. You cannot use it for making vertical pulls. Hoist suspended from a trolley system. 1.4.1 Operation of chain hoists. Hand chain hoist. To use a hand chain hoist, the rigger suspends the hoist above the load to be lifted using either the suspension hook or the trolley mount. The rigger then attaches the hook to the load and pulls the hand chain drop to raise the load. The load will either rise or fall depending on which side of the chain drop is pulled. That chain drop is just a continuous loop of chain. Depending on which way you turn it, it's going to turn the gear system, and it's going to either raise or lower the load. Powered chain hoist. To use an electric or pneumatic powered chain hoist, rigger positions the chain hoist on the trolley above the load and attaches the hook to the load and uses the control pad to operate the hoist. Only qualified persons may use powered chain hoists. 1.4.2 Hoist Safety and Maintenance. General safety rules are presented in the basic safety module. In addition to those general safety rules, there are some specific safety rules for working with hoists. Observe the following guidelines. Always use the appropriate personal protective equipment when working with and around any lifting operations. This includes a hard hat, safety glasses, safety shoes, and a high visibility vest. Make sure that the load is properly balanced and attached correctly to the hoist before a lift is attempted. Keep gears, chains, and ropes clean. Proper maintenance can shorten the working life of chains and ropes. Lubricate gears periodically to keep the wheels from freezing up. All such maintenance work must be done by a competent person. Never perform a lift of any size without proper supervision. So, never use a come-along for vertical overhead lifting. Use a come-along only to move loads horizontally over the ground. I like that. They're used to move heavy loads horizontally over the ground. Be careful not to confuse a come-along with a ratchet lever hoist. Ratchet lever hoists have both a friction type holding brake and a ratchet and pawl load control brake. Cable come-alongs have only a spring load ratchet that holds the pawl in place to secure the cable. If the ratchet and pawl fail, the overhead load will fall. So this is a ratchet lever hoist. A come-along looks very similar to that, but it does not have a braking system. It cannot be used for raising loads vertically. Hitches 1.5.0. In a rigging operation, the link between the load and the lifting device is often a sling made of synthetic alloy steel chain or wire rope material. The way the sling is arranged to hold the load is called the rigging configuration or the hitch. Hitches can be made using just the sling or by using connecting hardware as well. So there are three basic types of hitches: a vertical hitch, a choker hitch, or a basket hitch. One of the most important parts of the rigger's job is making sure that the load is held securely. The type of hitch the rigger uses depends on the type of load to be lifted. Different hitches are used to secure, for example, a load of pipes, a load of concrete slabs, or a load of heavy machinery. Controlling the movement of the load once the lift is in progress is another important part of a rigger's job. Therefore, the rigger must also consider the intended movement of the load when choosing a hitch. For example, some loads are lifted straight up and then straight down. Other loads are lifted up, turned in midair, and then set down in a completely different place. This section examines how each of three basic types of hitches is used, both to secure the load and to control its movement. Warning: all rigging operations are dangerous and extreme care must be used at all times. A straight up and down vertical lift is every bit as dangerous as a lift that involves rotating a load midair and moving it to a different place. Only a qualified person may select the hitch to be used in any rigging operation. So here's a vertical hitch. The single vertical hitch is used to lift loads straight up. Configuration forms a 90-degree angle between the hitch and the load. With this hitch, some type of attachment hardware, such as a shackle, is needed to connect the sling to the load. So here is a vertical hitch. It raises straight up and straight down. Another classification of hitch is the bridle hitch. The bridle hitch consists of two or more vertical hitches attached to the same hook, master link, or bull ring. So here is a bridle hitch. You've got two slings coming from a common point attached to the load. Multiple leg hitch consists of 3 or 4 single hitches attached to the same hook, master link, or bull ring. Multiple leg bridle hitches provide increased stability for the load being lifted. A multiple leg bridle hitch is always considered to have only 2 of the legs supporting the majority of the load and the rest of the legs balancing it. So multiple leg bridle hitch. Choker hitch. This is for moving pipes and things like that. The choker hitch is used when a load has no attachment points or when the attachment points are not practical for lifting. Choker hitch is made by wrapping the sling around the load and passing it through one of the eyes to form a constricting loop around the load. In many configurations, the sling is wrapped around the load and passed through a shackle to form a constricting loop. In those situations, it's important that the shackle used in the choker hitch be oriented properly, as shown in figure 46. Remember that the pressure of the load should never be placed on the pin of the shackle. So you make sure that the load, the moving part of the choker hitch is riding on the shackle itself, not on the pin. So that's a choker hitch. Choker hitch affects the capacity of the sling, reducing it by a minimum of 25%. This capacity reduction must be considered when choosing the proper sling. Further, the choker hitch does not grip the load securely. It's not recommended for loose bundles of materials because it tends to push loose items up and out of the choker. If you're carrying something, I think, more than 12 feet long, you want to use 2 choker hitches. When an item more than 12 feet long is being rigged, the general rule is to use 2 choker hitches spaced far enough apart to provide the stability needed to transport the load. So you're going to want to make a bridle hitch, and then each one of those bridles can be a choker around whatever it is that you're lifting. Figure 48, a double choker hitch. There you go. Here's the double choker hitch. And here's one in actual use. There's an actual picture. To lift a bundle of loose items such as pipe or structural steel, or to maintain a load in a certain position during transport, double wrap the choker hitch. Double wrap choker hitch is made by wrapping the sling completely around the load and then by wrapping the choke end around again and connecting the running end like a conventional choker hitch. So they go all the way around 360 degrees and then they come back and make the choker. And that has a better grip on this. It's less likely for any of this material to slip out or to fall. It's a double choker hitch. Forcing the choker down will drastically increase the stress placed on the sling at the choke point. The double wrap choker is used uses the load weight to provide the constricting force, so there's no need to force the sling down into a choker. It serves no purpose. As with a sling choker hitch, lifting a load longer than 12 feet requires 2 double wrap choker hitches. Basket hitch. Basket hitches are very versatile and can be used to lift a variety of loads. Basket hitch is formed by passing the sling around the load, or in some cases through the load, and placing both eyes in the hook. Placing a sling into a basket hitch has the effect of doubling the capacity of the sling. This is because the basket hitch creates 2 sling legs from one sling. So here they're going around the load and coming back up, making a basket hitch. A double wrap basket hitch combines the constricting power of a double wrap choker hitch with the capacity of advantage of a basket hitch. This means that it's able to hold a larger load more tightly. A double wrap basket hitch requires a considerably long sling length than a double wrap choker hitch, because you're going to go all the way around that material twice. If it's necessary to join 2 or more slings together, the load must be in contact with the sling body only, not with the hardware used to join the slings. Hand signals, we use the ASME. Now there's an emergency stop signal. I don't know if you can see me here, but now basically I'll show you the book here. It says a major aspect of rigging safety involves maintaining clear communication between the crane operator and the designated signal person on the ground. This communication is normally accomplished using common signals, either verbal signals given by radio or hand signals. Hand signals used in rigging operations in the United States have been developed and standardized by the American Society of Mechanical Engineers, ASME, for all cranes. With the exception of the emergency stop signal, hand signals can only be given by the designated signal person on the ground. The emergency stop signal, and this is highlighted, used in rigging operations. In the event of emergency, this signal can be given by anyone on the ground within sight of the crane operator. You might see something that the signal man doesn't, and you are allowed to give that emergency stop. Basically, you extend your arms out fully, and you're going back and forth, back and forth. That's an emergency stop signal. Warning, although this module provides instruction and information about common rigging equipment and hitch configurations, it does not provide any level of certification. Any questions about rigging procedures or equipment should be directed to an instructor or a supervisor. Always refer to the manufacturer's instructions for any type of rigging equipment. 1.0.0 section review says slings are commonly made out of synthetic fibers. Let's see here, what do they have here? Alloy steel and wire rope. If identification tag on a synthetic sling is missing or illegible, the sling must be removed from service immediately. The size of a shackle is determined by the diameter of its body, not the pin. A type of rigging equipment that uses a pulley system to provide a mechanical advantage for lifting a load is called a hoist. And when a load has no attachment points, or when the attachment points are not practical for lifting, it's best to use a choker hitch or even a double choker hitch. All right. Well, this concludes 00106 basic rigging. I hope that you got something out of this video. If you did, please consider giving me a like and a subscribe. I'd appreciate it, and I'll see you on the next video. Thank you. Hey, this is Brian Young. If you liked my video, please give it a thumbs up and consider subscribing. I'll see you on the next video.